Hello, everyone. Thank you for joining our webinar. Today, we're announcing Optimize Live V2, and we will talk through how we partnered with Acquia to reduce cloud costs and improve reliability. I'll kick it off with some introductions. My name is Yasmin Rajabi. I'm the VP of Product at StormForge, and then I'll hand it over to Erwin to introduce himself.
Hi, my name is Erwin Daria. Glad to be here. Thanks for everyone for joining. My name is Erwin Daria, and I'm the Director of Technical Alliances here at StormForge.
And I'm Ed Brennan. I'm the Chief Architect at Acquia, one of the first users of Optimize Live from StormForge.
Awesome. Super excited to have you both here and to get into the discussion. So today we're going to be talking about the challenge of optimizing Kubernetes. Anyone who's used Kubernetes in the past, I feel like can probably relate to some of these challenges. The biggest really being, you can go next, the efficiency challenge. So anytime I talk to users about setting resource settings, and I'm like, oh, how do you do this? It's always guesswork. It's, I look at a chart, add a buffer, and then I go with that. Or I take whatever the defaults were, what someone told me. There's not a lot of science behind it. And oftentimes, that'll work for one workload, but nobody ever has one workload. They have tens of thousands of workloads, and they all behave a little differently. They all operate under different load. And so when you get to actually configuring those applications at scale with Kubernetes, it becomes extremely difficult. And because it's, on one hand, easy to get up and running with Kubernetes, developers are, creating all their applications, deploying quickly. Generally, it's those platform teams that are left with managing the resources and dealing with this challenge, and they don't have all the ins and outs of the application or what it needs. And so this becomes even harder. And with a lot of teams right now, they're forced to kind of do more with less. So when they're looking at, okay, how do I right size this? They're kind of caught in that balance of how do I improve my costs without impacting my reliability? And the impact here, I'm sure everyone is feeling this already. Cloud growth has been growing at an unsustainable pace. And a lot of organizations are challenged with, how do I optimize my utilization? How do I look at my capacity? The CFO is telling me I need to get my costs under control, but the business units are driving the applications as quick as possible. So how do I really get to that balance? And really all that comes at the risk of app performance and reliability. If you get this wrong, you impact your business, and nobody wants to be the one that is responsible for the thing that impacted the business. What we've been seeing a lot, at least in the customers that I talk to, is that most of them, and I'm sure people relate to this, either are reducing their cloud spend this year or just trying to keep it even. So same as last year, really trying to get a handle over the cloud costs that are growing so much. But the biggest challenge to this is, sorry, next slide, that the Kubernetes skills gap makes this even harder to handle. If you're lucky, you have one or two really good Kubernetes experts that kind of can help paint the vision, help bring the team along, but most people are playing catch up. And it's hard to find those resources that can really help address this problem at scale. But what if you could right-size your Kubernetes application automatically, continuously, and without risking reliability? Not to be overly cheesy, but that's why we're introducing Optimize Live version 2. So what does Optimize Live do? We right-size Kubernetes applications to reduce costs and improve reliability. And the way that we do that is we take a look at the data. We have machine learning that analyzes the CPU and memory utilization, and will provide recommendations to right-size that application. If you have an HPA deployed, we'll also set the target utilization of that HPA so that we're properly vertically auto-scaling you in a way that is horizontally efficient. And we do this in an automatic and continuous way so that nobody has to think about it, right? You don't want to have to manually review things and deploy them. You want the software to take care of that. So we will continuously provide those recommendations and then take action on that in your environment. And our goal is to make it very fast and easy to set up. So you're spending less time kind of fiddling with the tool. And once you install it, you're up and started in a day. The key challenges that we've addressed with Optimize Live V2, the first one being time to value. Every Kubernetes engineer all they have to deal with are different Kubernetes tools, learning new things when it comes to Kubernetes. We don't want to be yet another thing you have to wrap your head around. So we want to make it super simple to remove the obstacles to Kubernetes optimization. That was a main goal in V2. And also really helping users understand the business impact of these changes. So it's not enough to just say, hey, we're changing your resources from X to Y, but what's the impact of changing it from X to Y? What are the cost estimates to that? What are the reliability estimates to that? How can you really feel confident about that? And operationally, when you are deploying changes to Kubernetes at scale, you need a little bit of confidence before you're ready to push that button and say, okay, the system can take over. So really looking at how we fit into workflows that large enterprises have already adopted and fitting into those workloads. So how does it actually work? We install an agent in the cluster and we discover workloads automatically, and the machine learning runs right away. We provide recommendations, and then users can implement those recommendations either automatically or through a manual workflow. Alternatively, if you want to integrate through a CI/CD process, maybe you have Argo CD, you have the ability to deploy recommendations that way as well. And this is a continuous loop. So as new workloads come up, we will discover those and provide recommendations. And you can run these recommendations every day, every 7 days, every hour. Really depends on the workload and the type of schedule that you'd like to run these on. So I don't want to, get too much into how it works theoretically. So I'll hand it over to Erwin to give us a demo.
Awesome. Thanks, Yasmin. I'm going to stop the share here as I get the demo all set up. Bear with me here. Where's my little Zoom? Okay. Is everybody able to see my two windows here? I've got a console window and I've got a web browser.
Yep.
Awesome. So yeah, thanks, Yasmin. I think you said it just a couple seconds ago, right? What we really want to be able to do is we want to allow these Kubernetes engineers, these folks that have hands-on, that have probably already too much on their plate, we want to give them the benefit of using all of our machine learning expertise, all of the recommendations that we can generate. We want to do it with as little overhead as possible. And so I deployed a Kubernetes cluster yesterday. I've got some workloads. I've got some load generators that are generating the metrics that our machine learning needs to analyze. And I did that a little bit yesterday. And I deployed the StormForge agent yesterday. Now, you've already mentioned it. StormForge Optimize Live is a machine learning based recommendation engine. So it needs data. And so that's the reason why I did this yesterday. But you can see on the screen, this is the Helm command that I use. Really simple. We're just pulling the agent from our registry. We're setting values for the version 2.0. And then we're creating a namespace. And then I have generated a token. This is part of our documentation. Anybody that goes and checks out our latest documentation will see that. But essentially, it's just a token that allows the container objects to authenticate against our backend and then communicate with the SaaS platform. Once I deploy the agent onto my cluster, you already heard it from Yasmin, the agent will automatically discover all of the workloads that are in the cluster. Optionally, you can choose filters. There may be situations where maybe you only want to see certain namespaces, maybe you want to exclude certain namespaces, but in the case of this demo, this is everything that we have in the deployment or in the cluster. Now, again, this is something that the customer doesn't have to do. All I've done so far to get to this point is deploy the agent. So the workloads have already been discovered. The machine learning has already been working for the last 24 hours. And you can see on the screen that it's already been making recommendations. When you go to the Optimize Live UI, you'll see your list of workloads, and they are stack ranked on relative and absolute impact. So one of the things that the system will automatically do is bubble up to the top of the list, all of the workloads, the ones that have the greatest impact from either an under-provisioned standpoint or an under-provisioned standpoint. So here you can see at the very top of my list is one of the workloads in my e-commerce application called the recommendation service. And the recommendation here is to add a pretty significant amount of resources. And I'll talk about that a little bit later. But first and foremost, I think the topic that's at hand is cloud savings or cloud cost savings. And a lot of organizations kind of think of it as, let me figure out like how to scan all of my workloads and then figure out how to turn down the volume knob on all of my resources. If I do that enough across enough workloads, and hopefully my bill will be reduced. One example of something that is over provisioned is something like this payment service. If I click on the payment service, there's a couple things I want to kind of see. I want to show right off the top here, right? Which is one, every workload that gets automatically discovered, the machine learning needs a certain amount of data to have really high confidence in its recommendations. So we put this banner here for customers just to let them know that, hey, even though I've deployed this agent, it automatically discovered the workload. The machine learning's been working on all the metrics for the last 24 hours. We really want to see 7 days of metrics before the recommendations are what we like to call like mature or valid. Now below that, you'll see a couple of really interesting pieces of data right away. And again, I haven't had to set this up. I don't have to worry about setting up dashboards and whatever observability tool that I might be using. All of this comes with the platform and gets automatically set up for you when you deploy the agent. And the data here at the top is really just a kind of before and a projected after, right? Which is, hey, here are my total requests and for my CPU and my memory. What does the machine learning think the value should be based on the data that it's seen so far? Again, with the caveat being that we've only seen 24 hours worth of data. And then I'll draw your attention to this overall efficiency widget here. This is meant to really show customers at a very high level immediately kind of the most impactful optimizations that they can make. So workloads with a really crazy efficiency, like a super high 200% efficiency, are going to be colored red. Ones with really low efficiency, like this one at 9%, are also going to be colored red. And what this is meant to illustrate is the difference between what my requests are and how much the workload is actually using. So again, if you've got a really low efficiency workload, I've given it a lot more requests, but it's not using very much. I can take a look at the details here by scrolling down, and you can see exactly what I just described. Here I have a workload with a request of a quarter of a core, but you can see that this an application, e-commerce microservices application. We have some load generators that are creating a randomized workload pattern against this application. But you can see that the usage is actually quite low compared to the requests. And so the machine learning is taking in that data and beginning to make recommendations and much more closely track what the utilization pattern is. Again, really useful for customers. Here, in the case of the CPU, you can see that it's massively over-provisioned by percentage. Same thing with memory. You can see that the memory isn't really being tasked at all, and the requests are still quite high. If I go back to my workloads, the second use case that I want to kind of visit is this recommendation service at the very top. You can see that the efficiency score is very high. I think ultimately most people might look at this and they might be super excited. This looks super efficient. And really what the machine learning is telling us and what the system is telling us is that you are using way more than the requests are set for this deployment. And you run the risk of running into either contention or performance issues with an application that has a configuration that's kind of like this. And you can see, again, the machine learning began looking at data and is now making recommendations that are much more safe from a utilization standpoint. So again, those are the two that you'll find a lot in a lot of organizations. I think it's really important for folks to understand that again, when we view this issue through the lens of cost savings, yes, absolutely. I think a lot of our customers will find that there's a good percentage of their deployments that are over provisioned, but there's equal risk and maybe even more detrimental risk in having under provisioned workloads, just from a performance standpoint, from escalations, from having to troubleshoot. And we want to be able to do that both. We want to be able to facilitate our customers being able to boost the efficiency and cost of their platforms, but we also want to catch these situations where they may be under provisioning workloads and then risking either CSAT or whatever metric KPI that you might be tracking. Now, if I go back to my workloads list, there's one more that I wanted to visit, and that is our front end. Now, I game the system, I gave our front end an HPA. But again, this is just to illustrate the power of being able to analyze this data and understand the context in which the application is being used and how it's configured. So when you have a workload that has an HPA, it absolutely looks exactly the same. We have an overall efficiency score. We've got the current configuration, which is inclusive of the total number of replicas at the time that this value is being calculated. And then we have a total optimized set of values. You can see here that the graphs all reflect the behavior of the HPA. You can see here that I've gone from 2 replicas down here in one of the valleys, and we go all the way up to 8 replicas. Now, this is what the HPA is designed to do when you have really bursty workloads that go up and go down, and you want to mitigate the over provisioning of a microservice, or you have a microservice that's architected to scale horizontally. This is exactly what you want to be able to see, but it takes a lot of time and energy to configure these things. And a lot of times the templates that we give to our developers for creating a application that has an HPA can be problematic. So you may find that you have deployments that look like this, where the machine learning recommendations are actually quite close to what the actual real world behavior is, but that's not always going to be the case. And it's really difficult to have confidence that this is actually the case when you have tens of thousands of deployments, some significant percentage of them having an HPA. Now, as we kind of continue to explore kind of Optimize Live, I want to kind of draw some attention to the recommendation details. Now, this is how you take a look at the actual details for all of the individual pods that make up the replicas in this HPA. So here we can see the actual average utilization across all the various pods. We can see the machine learning making recommendations. We can see what the requests are. We can see what the recommended limits are. So this is another interesting thing that we've implemented in Optimize Live. You can actually set both requests and limits. A lot of times we think about savings as just the request, but limits have an implication as well when it comes to making sure that you either are implementing something like a QoS or some type of you're trying to battle contention or whatever that might be. You want the machine learning to be able to find both, so that we can find this happy medium and we can limit the type of contention that we might see on the nodes themselves. Lastly, or maybe second to last, what we've seen so far, if I'm playing the role of a platform engineer or maybe an end user, I've done nothing. I've just deployed the application. I've passed the token so that my StormForge agent can communicate with our backend, and all the data that you've seen so far has been automatically discovered, and the machine learning has just been working. So everything that I've been describing so far is just really the byproduct of the platform working on its own. For customers that do want to have a few more knobs and levers, we do offer some more advanced configurations. There are ways that we can change the recommendation schedule. So to Yasmin's point earlier, when she was describing Optimize Live, we have customers that will change the recommendation schedule. Maybe they don't want to make a recommendation every day. Maybe they don't want to do it every hour. Maybe they want to do it every 7 days. There are all kinds of benefits to being able to do that. Check in recommendations that have a shelf life that lasts long enough that they can be integrated into a CI/CD, and you don't have to worry about passing stale recommendations. That is one concern that we help alleviate with this level of flexibility. The other thing that we can do is that we can optimize on specific goals. So the machine learning can get really aggressive when it comes to saving money, which basically means lowering the requests as much as possible. But we can also change this to reliability, so that the machine learning will add an error factor, a cushion to the recommendation, so that in any situation where there may be some unforeseen usage pattern, that you have a little bit of safety there. Now we have safety both in limits and requests, but changing the balance can be done here. When there's an HPA, we can actually bound the target utilization metric. I don't know if I covered this, but if we look at the recommendation details, there's a little widget here that shows you how the target utilization value should be set if you change the vertical scale of the request. So without getting into the weeds too much for the audience, obviously if you set a 65% average target utilization for an HPA at 500 millicores, that's going to be really different if you change it to 350 millicores. That 65%, whatever, needs to be adjusted so that the scale points stay the same. We offer a bunch of other knobs and levers. I don't want to get into too much detail here, but we allow the customers who really have, as much as we like to think of these as like pets versus cattle, sometimes these deployments are still pets, and we care about tuning them, fine-tuning the behavior of the machine learning so that we get the exact right behaviors. And in this case, you can actually tell it, hey, don't optimize the CPU, don't optimize memory. There could be a lot of reasons why that is. And we can add some more gates and guidelines for the machine learning. So whether that be minimum and maximum CPU requests and limits, or minimum and maximum memory requests and limits, we can certainly implement those as well. Lastly is the piece that Yasmin had discussed around giving our customers the flexibility of being able to take action. So we have this tool that doesn't require a lot of overhead. You deploy it, automatically discovers all of the workloads, machine learning automatically makes recommendations. Now it's how do I take action? And we allow our customers a lot of flexibility in the ability to do that. So first and foremost, you can either, what a lot of our customers will do is everything that you're seeing so far, we actually can offer through the API as well. But whenever these recommendations are surfaced, you can download them as YAML objects, as JSON objects. You're using the CLI. You can integrate them into a CI/CD using those objects. We give you a pre-formatted command that allows you to do it through a console, and that's the manual elements. You can imagine that a customer that's just using this, maybe they don't trust an automatic application of these requests. Maybe they've got a process for making sure that they're checking in source code that has to do with their infrastructure. Then we can certainly support that by giving them the handles and the knobs to extract these artifacts and integrate them in the way that they want. Kind of in that crawl, walk, run mode or model. Maybe the walk would be coming into the UI, maybe having somebody that has the right access control to just hit the apply now button. So optionally, we allow customers to deploy a component as part of Optimize Live called the applier. It is a application that just looks for recommendations that have been tagged. When I mean tagged, I mean by hitting this apply now button, it means that the application or the recommendation is set to apply. The applier will then apply it directly to the cluster. And then lastly would be this automatic deployment, so that you don't have to come in here, you don't have to press any buttons. Maybe there are a lot of customers that maybe don't want to integrate into a CI/CD, or maybe they have something that's like Argo that's controlling the deployments, but they've configured it to ignore things like CPU and memory. So they have something like a GitOps framework that's controlling all kinds of other aspects of the application and standardizing on those. But the CPU and memory is much more fungible. They allow these changes to happen. Again, the crawl, walk, run as you gain confidence in the machine learning and you're continuing to see the value. We find that a lot of customers will go into this automatic deployment as well. So once you set this to on, the system will automatically apply the recommendations at the interval that you set here. So that is ultimately how our customers are able to, one, just very easily deploy the tool, allow us to do all the work. Well, not really me or Yasmin, but allow our machine learning to do all the work. And then we give the customer a really flexible choose your own adventure kind of model for how best to, one, gain confidence in the recommendations that we're making, and then take action as they see fit. So with that, I'll go ahead and stop my share. We'll go back to the presentation. I'll hand it back to Yasmin.
Awesome. Thank you. That was awesome. Appreciate you going through the demo. And now for the next part, which will be my favorite part of the webinar. Sorry, Erwin. Okay. I will hand over to Ed, who's been just an incredible partner as we build out Op Live. Been working with us for what, the last 3 years, 4 years, Ed?
Yes.
Quite a while. And I mean, I say partner because it's not like any typical customer, really just helping us with our roadmap, our technical solutions, providing feedback, just helping us learn what some of the large Kubernetes challenges are. So I'm very excited for story time with Acquia and Ed.
Thanks, Yasmin. And the feeling is mutual between Acquia and StormForge. I think we've partnered well together in getting to where we are. To give the audience some idea of what we do, Acquia is a place where you can host digital experiences, and we do those digital experiences at scale. So our circumstances were a little bit unique, where our customers and what we host is brought in by our customer itself. They'll bring their own code and they'll deploy it on our platform, and that platform will then manage it and make sure it's available, scalable, and secure. And so when we did this, we decided to build this new platform where we were going from tens of thousands of EC2 nodes over into a Kubernetes infrastructure. In that the legacy environment, we had about 30,000 applications deployed, and we're moving those into a Kubernetes infrastructure. And so we decided to roll this out to look at delivering value first to our customers, build out the platform, get all the platform ready, stable, secure, ready to scale for our customers. and not worry about it cost as much. We had a model that said it would save us money over time, but anybody who goes into this container space and thinks that just deploying containers is going to save you money day two is just kind of fooling themselves with the buzzword container. And so we rolled it out for our customers. We got the customers running. We learned from those customers what it was looking like, what those Drupal applications would run like in the environment. And then we moved on to a phase two, which is really the optimizing, to bring the cost in line with the business model we had, but also ensuring that our customers have the resources they need when they needed them, whether it was to optimize the cost or not. It was really about right-sizing the customer's environment based upon how they were using the environment. And again, we don't control how they're using it, their customers do. So we have to kind of rely on the machine learning that we've put in place with StormForge to help us do that, because it's not just about optimizing our cost, but it's also delivering the experience that they want to deliver for their customers. So making sure that they have the right resources when they need them. So as everyone was talking during the demo, it showed somewhere StormForge recommends upsizing those requests, not downsizing them. Kind of opposite of the whole cost optimization. But when we rolled this out, we found that when we were doing it before, we had customers that had more pods than they really needed. So although StormForge is recommending the increase of pod sizes, we reduced the number of pods, which also then just reduced the cost as well. So we were able to reduce cost in many different ways while still ensuring the customers had the right resources when they needed them to serve their customers. And we did have a target to reduce our platform costs by about $1 million last year. You know, we had rolled it out. We started rolling our customers onto it. We got a good percentage of our customers migrated over, but the costs weren't in line with our projections for our business. And so we put a cost target out there, and working with StormForge, we were able to actually meet that cost target of saving that $1 million on that infrastructure. Next slide, Erwin. And so how do we roll it out is the next question, right? Do you roll it out across everything all the time? We've got over 30 clusters in the environment. We've got, I don't know, tens of thousands of pods running at any given time in the environment. So the last thing you really want to do is just roll it out across the entire infrastructure. So we rolled out StormForge to some of our non-production infrastructures first, saw how it was working, let it soak in that infrastructure for a period of time, make sure everything was running as we expected, did our performance testing, did our unit testing, did all the testing we needed to make sure that everything was still stable as we needed it to be. Then what we did is we started putting this into our production clusters, but not on the customer's production applications first. We went out to non-production infrastructures first, and only a subset of those within a couple of clusters. And we let that sit for a period of time while we viewed what it was doing, whether the customers were happy with what they were seeing, and ensuring that we were still meeting our SLAs and the customers' applications were performing as expected. Once we did that, we rolled out across all of the clusters for the non-production environments. And then again, let that sit for a period of time where we made sure that all the same things were happening again, right? Customers' applications were performing as they expected. Our costs were coming in line with what we expected. And then from there, we then rolled it out across our customer production environments. Again, smaller clusters first into larger clusters. It was just a step-by-step approach to rolling this out. We trusted from the engineering and platform side the machine learning, but we needed to make sure that everybody came along for the ride because not everybody understands requests versus limits and those types of inner workings of Kubernetes itself. And so it was about rolling it out where everybody was comfortable, and we were able to see the cost savings were coming in line with what we expected it to do. Next slide, Arlie. And so our $1 million challenge really was about cost benefits. Can we get to the cost benefits we had? But really, the partnership with StormForge and what we were trying to do was more than just the cost benefits. Cost benefits was part of the platform business plan itself, but there are other savings or benefits you get with this kind of a deployment. With us, our customers, as I said, bring their own code, and that code changes frequently over time. And so trying to ensure that you have the right requests at the right time based upon the latest release was problematic from an engineering perspective to try to solve. I mean, you just do a small, medium, and large and deploy them in that way. And then when they start having problems, you change the size. That's not an efficient way or a way to deliver a good experience for your customers. So we always wanted to do this machine learning piece. And so the operational benefits is we didn't have to build that ourselves. We didn't have to have an engineering perspective. We didn't have to have teams going in and manually upsizing or downsizing these requests to make sure that they're always in line with what we wanted them to be for our customers' experience and from our, from our cost side of the house. And then customer benefits, right? Again, the customer's code is changing all the time. And so one deployment from another could be using more or less requests. And so this will allow us to dynamically size those requests so that we can ensure that our customers are getting the expected performance from their platform, the expected experience from that platform, and their customers are always able to get into their sites and do what that experience is supposed to do, whether it be a college delivering some sort of a curriculum to their students, or some sort of a retail customer delivering an experience to their customers. We kind of span the globe on all those different experiences, and so we always wanted to make sure that our customers' uptime and SLAs were always adhered to, and this has allowed us to do that. I think that's the last slide from me, Aaron.
Yeah, that's awesome.
Some
yeah,
questions?
Questions? I mean, I have a question before we actually get to the Q&A. I imagine that we were able to help Acquia with its $1 million challenge. So the cost benefits, they're a little bit non-specific here on this slide, I think for really good reason, but I think it speaks to our partnership and how we worked together over the years, that you trust us to help contribute such a meaningful percentage to whatever your cost optimization goals have been and will continue to be.
And Ed, I have a question for you, and I'll preview this with, I've kind of heard some of the answers as you talk to other very large enterprises, but what were some of the hardest challenges when it came to operating Kubernetes at scale that you all dealt with before you kind of took this more machine learning plus automation based approach?
Yeah, sure. So education was probably the biggest challenge I think we had from that perspective, making sure that we educated the right people on the right things, especially when you get up into more of the executive layer. It is difficult to really kind of explain some of the intricacies and complexities of Kubernetes. But even that being said, at the technical layer, getting folks to understand what requests versus limits are, for example, in HPAs, and what the proper HPAs might be, and actually getting teams to actually understand what their limits and requests should be based upon what they've had in the past from legacy systems. They're very, very different things. And so we had to really work with a lot of different teams, a lot of different business units within our organization to help understand this as we roll this out, to help get people on board with, we're going to dynamically change things on you and you're not going to see it, so don't worry about it, was something you have to get through, right? And so trying to explain the difference between, we're only going to set requests versus limits, for example, ensuring that you still have all the availability you need of the resources you need, was very difficult. So it really was a lot of education, but both up and down the stack when it comes to rolling out Kubernetes at scale.
Appreciate that. And from your perspective, how often should people be right-sizing?
That's an interesting question, and probably changes with each environment in reality. I can tell you right now, we optimize once every 7 days for the majority of our workloads. But I think there's opportunities to change that to be more dynamic over time. So for example, maybe you can do it during the morning when some of the sites are getting more traffic because it's now production in the US East, for example, while at night you can reduce those requests, reduce your footprint, which then reduces your cost. But not only your cost, your security profile right at the end of the day, because now you're reducing your footprint. So there's a lot of benefits from doing it at the right times. Other times could be hourly, right, for different resources. So we are working through some of that at this time, but I also think each team, each workload will have differences in how often is the optimal way to do that. I also don't think there's a lot of use in doing it too often either, right? Where you're causing a lot of pod churn within the infrastructure. And that pod churn then causes back pressure on the backplane. So now you're working on the EKS APIs, and maybe you're hitting them too much because you're spinning pods up and down. And so I think there's a happy medium, and it's really about the workloads you have and what your goals are as an organization.
Yeah, that's
awesome,
a great
Ed.
point.
Yeah, exactly. I have a question for you, Ed. I mean, so for customers that are, and you've been kind of front seat on the journey with Acquia, obviously with StormForge over the last number of years. But for organizations that are like just getting started, maybe even just looking at optimization, like, do you have any advice for them? Like, where key areas to focus on? You know, where should they spend their nickels first?
Yeah, and we spent a lot of time in that in the beginning of our venture into Kubernetes and trying to figure out exactly where to spend our time when it came to that. And so we did start out with, not as much focus on optimization as we did on availability and the performance of the applications themselves. But start simple, right? CPU and memory are is what you're going to look at, and try to get those as close to the limits. The request versus the limits as close together as possible, and try to figure out what the node sizes you want to have, right? Because that's also a way you're going to more densely pack your environments, is matching your nodes to the right workloads. We call it shaping of the nodes. And that really means, are the right nodes in place to support your workloads? Are you more CPU intensive or memory intensive? And based upon that, you choose C's or M's, for example. So start simple with the the out of the box pieces, which is CPU and memory, matching those to no different node types, and then trying to make sure that with StormForge you can pack those as densely as possible by having the right requests put to those workloads and matching those to the limits on the CPU configurations for the Kubernetes infrastructure.
That's excellent. All right, should we go to a Q&A, Yasmin?
Yeah, let's see what questions have come in. Ed, for you, and you kind of touched on this a little bit, but how hard was it for you to make the case to buy a tool, especially when a lot of organizations are asking to cut down on tooling and tool costs?
Yeah, the business case for StormForge was somewhat simple in reality, where from an engineering side, I saw the benefits right away. Because our teams didn't focus on it. We focused on things that could deliver value to our customers, not infrastructure in the platform itself. But with the executive layer, it was about building the business case. You're going to spend this much money on the tool. How much are you going to save out of it, and prove you're going to save that from that tool over time? And so from that perspective, we put that business case together, working with StormForge based upon what we knew about the environment, based upon some of the things we did some early on testing with Optimize Pro at the time, looking at some of our larger clients and looking at what we could save from those clients, and then trying to extrapolate over time what that would then lead into from the rest of the customers migrating over. So from that business case, it was, basically, here's where you are today, here's where you are tomorrow, this is what you would save, and this is the engineering effort you would save by getting there, by doing it this way.
Awesome. I appreciate that. Yeah, and that was a good answer, because I think it was a little bit of a journey, right? And kind of showing that data. And it's a question that honestly I come across often talking to users too, where they're like, well, I have to spend money to save money. I need to have that business case. So that's a really good point.
Yep.
This is an easy one, so I'll take it. Do you support free trials? Yes, we do. So if you want to sign up for a trial, you can on our website, and then we'll reach out with a trial license, and you can get started from there. And then there's another one, Erwin, if you want to take this one. Do we deploy on cloud marketplaces?
Yeah, so today we're available on the AWS marketplace. Now, it's not a container offering. So those of you that are familiar with all the various types of offerings you can have at the AWS marketplace, this is a SaaS offering. It allows us to, if you're a customer, you have a substantial EDP, you want to do some drawdown, you want to spend some money using the marketplace, that is the vehicle that we use to do it. I would keep your eyes and ears open on this space for announcements for additional marketplaces. We're working with all the largest cloud marketplaces to make sure that our customers that host Kubernetes environments in each of those major clouds will also have access to the actual container offering. So just keep an eye out.
There's a follow-up. So can I use AWS credits for this?
Yes, so you certainly can. The way that normally that would work for, again, whoever asked that question knows the kind of the inner workings of AWS. As long as we facilitate through the marketplace with our current SaaS offering, we can do a private offer, which you can then use your AWS credits to pay for.
Awesome, thanks. Another question. Can your machine learning make recommendations outside of CPU and memory? That's gonna like that one. Nodes, CPU architectures,
I didn't put that
clouds.
in there.
Yeah, I'm wondering, Ed, did you put that? So today we support any Kubernetes deployment, so it doesn't matter which cloud, we can optimize it. And the question around nodes and outside of CPU and memory. So today we operate at the pod level, and our recommendations are just requests and limits, and then target utilization, of course. So really around just resources. But as we work with folks like Ed, really looking at what else can we, one, provide recommendations on, and what other data should we use as an input to the recommendation. So I'd say stay tuned. There are things on the roadmap that we are looking at, and we'll be able to provide recommendations for in the future. We have another product, Optimize Pro, that kind of goes deeper today. But from a live perspective, today we support CPU and memory requests and limits. And if you could wave your wand and we could make recommendations beyond just CPU and memory, what would you like to see?
You don't want me to start that conversation. We'll take up the rest of the meeting. But...
That's true. That's a good point. That's a good point. We'll save the wish list for later. And then just kind of before we kick off, Ed, any advice to people who are really in the thick of this right now and are trying to wrap their heads around where to start?
Yeah, it's about start early. Don't wait till you've got tens or hundreds or even multiple tens of clusters out there, and tens of thousands of pods and running all the time. Start early, and start with getting that knowledge early and education early, so you can understand the differences between limits and requests and HBAs, and how to tune those more accurately and match those to infrastructure types. Because the sooner you get on the path, the better off you would be.
It's great advice as always. So if anyone wants to learn more about StormForge, you can check us out at stormforge.io. And if you want to learn more about Acquia, you can take a look at acquia.com. And for anyone attending PlatformCon, we're super excited that we have 2 speakers there this year, Niels and, well, feels weird to call him Brian, we call him Lico, but there'll be 2 really great talks. So if you are attending, please go check those out. And I just want to wrap up one with a very, very, very special thank you to Ed for joining us, and just for all the partnership and guidance across the last few years. It's much appreciated, and really excited about what we're going to do next. And thank you, Erwin, for a phenomenal demo. And thank you for everyone that joined today. We're super excited to have you here.
Awesome. Thanks, everyone. Thanks, Ed.
Thanks all.